Bohdi Park, NEET and G Academy. Your dream, our mission.
Hello everyone, welcome to this physics session from Bohdi Park NEET and J Academy. Today we are going to discuss 10 MCQs based on graphs in kinematics. Okay, so welcome to Bohdi Park. You can find the link in the description for our app. You can download the app and have access to various study materials which is important for your NEET and JEE preparation. So let's start with the first question. Now look at this first question. It is the velocity time graph. The concept is slope of velocity time graph is acceleration and area under velocity time graph is displacement. So let us check the question. What is asked? From the velocity time graph, ratio of average velocity. So average velocity is equal to displacement by time delta x by delta t for interval 3 seconds and instantaneous velocity at 3 seconds. Instantaneous velocity means at 3 seconds. So at 3 seconds instantaneous velocity is 6 meter per second and average velocity from 0 to 3 seconds. 0 to 3 seconds, it will be area under Vt graph divided by time taken 3 minus 0. So 0 to 3, this will be the area. So this area is equal to half into base into height. So this will be 9. So displacement is 9 meter, time is 3 seconds. So this is 3 meter per second. So average velocity is 3, instantaneous velocity is 6. So 3 by 6 or 1:2. That's our answer. Now next question. Question number 2. Now look at this question number 2. Two objects are moving in a straight line. Their position versus time graphs are in figure. What is the relative velocity of A with respect to B? So VAB is equal to VA minus VB. Now velocity means slope of xt graph, slope of xt graph. So we have the slope for these two graphs OA, or suppose A and B. So for A, slope is equal to tan 37 degree, and for B, slope is equal to, now see, for B, this is the angle theta. So slope is equal to tan theta, and this is 90 degree. So this is 37. This angle is 37. It is like this. This is theta, and this is 37. So tan theta can be written as tan 180 minus 37. So that will be minus 37 degree. Tan 180 minus theta is minus tan theta. Tan 180 minus theta is minus tan theta. So, or let's say this is alpha. So tan 180 minus alpha is minus tan alpha. So alpha is 37 here. Alpha is 37. So tan theta is minus tan 37. So tan 37 is using this triangle 3, 4, 5. This is 53, this is 37. So tan 37 is 3 by 4. So velocity of B is minus 3 by 4. Velocity of A is 3 by 4. So VAB is equal to VA minus VB. So 3 by 4 minus 3 by 4. So it will be 3 plus 3 by 4. So 3 by 2. So third option. Okay, done. Now next question. Now look at question number 3. Velocity versus time graph of a particle moving along straight line is shown in the figure. So this is the velocity time graph, and we have to find during the interval 0 to 6 seconds magnitude of displacement and distance traveled. So concept here is for VT graph, area under VT graph is equal to displacement, and if the displacement is positive, so distance is same as displacement. If displacement is negative, so take the magnitude for distance. So how much is positive displacement and how much is negative displacement, we will find. So 0 to 6 seconds, you see this area is positive and this area is negative. So positive displacement means rightward displacement is, now find this area, so half into base into height. So this is 20 meter and leftward displacement is half into base into height, so minus 10 meter. So we have to find magnitude of displacement. So net displacement, first displacement plus second displacement, total displacement is 10 meter. Okay, and total distance, now distance we have to take magnitude of both the displacements. So rightward it is going 20, leftward it is going 10. So total distance is 20 plus 10 is equal to 30 meter. Now the magnitude of displacement is 10 and distance is 30. So 10 by 30. Second option. Now done. Now next question. Next question, we have to consider particle start moving from rest with constant acceleration. So acceleration is constant, initial velocity 0. Which of the following graph best shows the variation of speed versus distance graph? So we have v square minus u square is equal to 2as and initial velocity 0. So the particle is going along straight line. So velocity, final velocity square minus 0 square is equal to 2as. So v square is proportional to s. So the speed is increasing and it will follow parabola. So this is parabolic graph. So we have v square is equal to 2a, which is constant, into s. So whose power is 1, the parabola will open along that. So power of s is 1. So parabola will open along s. So suppose if we plot v along y-axis s along x-axis. So the parabola will be like this. So we have to consider positive velocity because acceleration is positive. If we assume like that, if acceleration positive, so velocity positive. If acceleration negative, so velocity negative. So this will be the graph, positive side. So third option, okay, parabola. Finish. Now next question. Now fifth question, acceleration versus time graph for a body moving along straight line as shown in the figure. If at t is equal to 0, body start from rest. So that means the initial velocity at t is equal to 0, initial velocity is 0. Select the correct statement. Now first statement says body has same velocity at 6 second and 10 second. At 6 second and 10 second. So how to solve this type of question? The clue here is, the concept here is the area under acceleration time graph. Area under AT graph, area under acceleration time graph gives change in velocity. Change in velocity. So change in velocity is delta V. So if we want to check the first option, it is saying same velocity at 6 and 10. So change in velocity must be 0. So 6 and 10, if we consider 6 to 8 and 8 to 10, you observe one area is positive, other area is negative, and both are equal. So this area is half into base into height, and this area is minus half into base into height. So both are positive, negative, magnitude equal. So total area is 0. So delta V is 0. Okay. So velocity at 6 and 10 second are equal. So first option correct. Body has maximum speed at 8 second. So you see at t is equal to 0, velocity is 0 and acceleration is positive. Acceleration is positive, so velocity will be positive and velocity will increase. Velocity will increase till acceleration is along velocity. So basically velocity positive, so acceleration also positive. So when acceleration is positive, the velocity will keep on increasing. So acceleration positive, acceleration positive, acceleration positive up to 8 seconds. So acceleration is positive up to 8 seconds. So velocity will increase up to 8 seconds. So maximum velocity is at 8 seconds. After 8 seconds, the acceleration becomes negative. After 8 seconds, velocity is right side, acceleration is left side. So velocity will start decreasing. Okay. So second option also correct. Body has maximum speed at 8 seconds. Next, motion is uniformly accelerated. Uniformly accelerated means acceleration is constant. So the graph will be parallel to time axis. So between 2 to 6 seconds. So 2 to 6 seconds, the graph is parallel to time axis. So acceleration is constant. So it is uniformly accelerated motion. So third option also correct. So basically our answer is all of these. Fourth option. Now next question. Now look at this question. In this question, what is given? AT graph. So the area under AT graph is velocity change in velocity. Area under acceleration time is equal to change in velocity. Now over here, the acceleration time graph of particle moving along straight line, the time taken by the particle to acquire initial velocity. So final velocity is equal to initial velocity. So the change in velocity is 0. So positive area is equal to negative area. Total area is 0. Now over here you observe this area is positive. So we have to select equal negative area. If I extend this graph like this, so I want equal area in magnitude wise. So symmetrically we can check, this is 2 seconds, so this is also 2 seconds. So 0 to 4 seconds. So this will be 4 seconds. So at 4 seconds, the total area becomes 0. So delta V becomes 0. So total time taken will be 4 seconds. So first option. Now next question. Now, seventh question, it is the velocity time graph. Seventh question, it is the Vx graph. It is velocity position graph. So, slope will be dv by dx. Now, in this question, we have to find acceleration at 4 meter. So we have to use the formula of acceleration v dv by dx. Okay, how to get this formula? We know that acceleration is dv by dt. So acceleration is dv by dt, multiply and divide by dx. So this dx by dt will become v. So v into dv by dx. Now at 4 meter, velocity is 4 meter per second. So acceleration will be 4 into dv by dx. Now dv by dx is the slope. So for slope, we will use tan theta formula. Slope is equal to tan theta, and we can also find tan alpha. So tan theta will be equal to minus tan alpha. Now to calculate tan alpha, this is alpha. So tan alpha will be opposite 4 by adjacent 2. So dv by dx is equal to minus 4 by 2. That is equal to minus 2. So acceleration is equal to 4 into minus 2. So answer is minus 8 meter per second square. Okay, this type of questions are very important and tricky also. So first option. Okay, finish. Now next question. Now in this question number 8, it is given that Vx graph. Again, what is the acceleration? So you have to tell whether acceleration is constant or is it increasing with time or decreasing with time, or information is insufficient. So the formula for acceleration is equal to v dv by dx. So if you look at this graph, velocity is increasing with position. So basically velocity is increasing with time also. So velocity is increasing. And what about dv by dx? So dv by dx is the slope. So it is a straight line graph. So a straight line graph means slope is constant. For a straight line graph, slope is constant. So we have v increasing and dv by dx constant. So acceleration increasing. So we have second option correct. Done. Now next question. Now question number 9. So question number 9, for the given acceleration versus time graph of body initially at rest. So u is equal to 0 and velocity versus time graph is given. You have to find. So you have to find a vt graph when at graph is given. So let's use the concept of integration, because we know that dv by dt is equal to a. So dv is equal to a dt, and when time is 0, velocity is 0. After time t, the velocity is v. So now we have to find acceleration as a function of time. Find acceleration in terms of t. So using this graph, so suppose this angle is alpha, so we can find the equation using y is equal to mx plus c. So y is equal to mx plus c. C is 0 because the graph, so y is equal to mx plus c. So suppose c is a naught, okay, initial acceleration is a naught. So c is positive and slope will be minus tan alpha. So minus tan alpha into t. So a is equal to minus some constant c1 into t plus another constant c2. Now this a you put here, so you will get minus c1t plus c2 into dt. Now integrate this, so we will get minus c1 into t square by 2 plus c2 into t, and on the left side we will get v. After substituting the limits 0 to t and 0 to v, we get v is equal to minus c1 by 2 t square plus c2 into t. So this is the equation. Now at t is equal to 0, velocity is 0. That is correct. So it is a parabola. So now we have to find the nature of parabola. So if you observe, so v, the power of v is 1 and the power of t is 2. So the parabola will open along v, and this constant is negative. So parabola will open along negative v. So parabola open along negative v. Negative v means down. So the parabola will look like this. So I think they are asking speed versus time graph. So this portion we will do, this is negative, so it will be positive like this. So fourth option. Done. Now next question. In this 10th question, a ball of mass m is pushed from origin. This is the origin, and for this origin, this x value is 0. The velocity of this ball is v in the rightward direction. Okay, so initial velocity is positive and right side. So slope for xt graph, slope is velocity. So t is equal to 0. The xt graph slope is positive. So if we observe first graph, so initial slope is positive, and second graph also initial slope is positive. Fourth graph initial slope is negative, so fourth option is wrong. And third is also wrong, because the slope is constant, because velocity is constant, so it is a smooth surface. It is not mentioned in the question. We have to assume it is a smooth surface, so velocity will be constant, so slope is constant. So in third graph, the graph is not a straight line, it is a parabola or something else, but not a straight line, so slope is not constant. Clear? So third cannot be the answer. Now, so it will hit the ground, it will hit the wall. This is the wall, then it will rebound. So immediately after that, the velocity will become negative. Suppose plus 1 meter per second, after rebound minus 1 meter per second. So slope will become negative. So it is mentioned in this graph. So for some time the slope is positive, and for next time interval the slope is negative. Then again it will hit this wall and the velocity will reverse. So at this time the velocity becomes, it will change from negative to positive. So first is correct answer. Okay, done. Okay, thank you.